are going to be solving is question 4. It reads, a mass of 98 grams of sulfuric acid, H2SO4, is dissolved in water to prepare a 0.500 molarity solution. What is the volume of this solution? Okay, now this problem is a little different from the problems that we have solved before, only in that it is asking for the volume instead of the mass or even the molar concentration. Pretty much a little bit more of the same thing, only slightly different. Okay, so as always, we will start by stating what we are finding. N equals the volume of H2SO4, sulfuric acid. We state our given. We have 98 grams and a molarity 0.500, and as per usual we're going to find our molecular weight. State your atoms. Atomic weight of 1, atomic weight of 32, atomic weight of 16 times 1 times 4 times 2 to give you a molecular weight of 92 grams per mole. Okay, nice. So that is the brunt of our initial work. We can start solving. So what we should notice here is that we are going to have to start with our unit conversion to go from grams to moles. Alright. Nothing too serious, nothing too serious. So we're going to start with our simplest unit, which would be our 98 grams, making sure that our units cancel. To get our desired units of mole. So we have 98, 98. Alright, let's go get our calculator, right? Because, 98 over 98 obviously doesn't equal 1, right? Of course, that's sarcasm. It does equal 1. 98 over 98 equals 1. So, for every 1 mole, there is 98 grams, and we have 98 grams, which means that we have 1 mole to use to make this solution. Don't you just love it when things are simple? Because I certainly do. Okay, but will they stay simple for long? That is the question, and they will. Now, the next thing that you need to know, the next thing that will help you is to remember that molarity, okay, equals moles over liters, which is equal to moles times 1 over liters, which is equal to moles times liters to the negative 1. Remember how, if you've seen my previous videos, which you probably haven't, in my previous videos I keep stressing this because it can be helpful. This is about to be very, very helpful. Okay. As far as it'll help you to really understand the equation that we are about to use. Okay, so our base equation, and there's a reason why I say base equation, is molarity equals moles over liters, our base. What we have to do now is we have to adjust our equation so that we can find liters instead of moles. Because obviously we're looking for volume, and we obviously are looking for liters because we are looking for volume, because these things go hand in hand. Yes. So we'll go ahead and begin trying to adjust our equation. Now this is why I say that this relationship will come in handy. I'm going to rewrite this. Oh. Molarity equals moles times liters to the negative 1. Once again, these are the same thing. They mean the exact same thing. In my very first video, which solves question 1, I proved this mathematically. This is true. This will always be true as long as you do it correctly. It is true. Okay. So what we're going to do now is we're going to divide our moles. This will go away, giving us molarity over moles equals liters to the negative 1. Now we're going to take everything on both sides of the equation, because we need to get rid of this negative 1, and take everything on both sides of the equation to the negative first power. This will give you moles over milliliters equals liters. Why, you ask? Well, negative 1 basically means that whatever it is applied to is basically a reciprocal of itself. And I can prove this mathematically. Take a look at this calculator, right? So 9 to the power of negative 1 equals 1 over 9. 1, 5, a bunch of random numbers. That's too many random numbers. I don't know why I put so many random numbers. To the power of negative 1 equals random numbers, 1 over random numbers. 6 to the power of negative 1 is 1 over 6. These are reciprocals. So basically what's happening in this equation is everything is just basically being turned over. Essentially. These will cancel, and this just flips. Pretty simple, and this is what you get. The reciprocal, which is moles over milliliters. This, not this. You can, but it's a little more complicated once you start adding numbers, is what you're working with. This, yes, this, not this. If you do it this way, if you go ahead and you simplify your equation, isolate the variable, isolate the variable, isolate the variable, one more time for the people in the back, isolate the variable that you are solving for, you will reduce the amount of error that you get when you actually do your calculations. Because once you start plugging your numbers into here, then things start getting confusing, and now you're just lost. Here, it's just a bunch of symbols and letters. There's no 6-digit, there's not some 6-digit number to remember. There's no making sure your decimal places are in the correct place. It's just these 3 things that you have to work with. The simplest way to ensure that your problems are as correct as they possibly can be. So I'm going to change our equation. Equation now equals moles, moles over milliliters equals liters. Okay, looking back at our given, we have everything we need. Oh, moles over milliliters. I said moles over milliliters. I meant moles over molarity. We have both our moles and our molarity. Everything is working out beautifully, right? Yes. So it would be 1 mole over 0.500 molarity equals liters. Let's get our calculator. Handy dandy calculator. 1 over 0.500 equals 2. 2 equals liters. Okay, and now we check. With our original base equation, which is, we just plug in our 1 mole and our 2 liters to give us 0.5. Now I didn't use a calculator for this one because I didn't need one, because this one actually was very simple. Very simple problem with some nice complicated components. But yeah, so n equals 2 liters. And that is how you solve and check for n equals the volume of sulfuric acid, H2SO4. Thank you for watching. Bye.